And when we're talking about soil physical properties, things such as the tendency to fit together into aggregates or clods, the aggregate stability of the soil, the water relations in the soil, such as intake and holding capacity, and also, to a certain extent, some chemical properties, such as the ability of that soil to hold ions on the soil particle surfaces. These are all greatly influenced by the surface area in a given volume of soil. A change of a few percentage points of clay in the soil will have a much greater influence upon surface relationships than will a corresponding change of a much higher percentage of sand or silt-sized particles. So we're going to be looking in a later unit at these clay-sized particles, the types of minerals that are composed in these secondary clay minerals, and looking at how they influence, or what great influence they do have on both physical and chemical properties of the soil. As I've indicated earlier, the sand, the silt, and the clay-sized particles fall into specific effective diameter ranges. Now we take the sand category and break it into some subcategories. And we need to do this because if we look at the size range of sand particles, we're talking about from 0.05 up through 2.0 millimeters in terms of effective diameter. That is a huge range of size differential in those particles from the lower end to the upper end of that range. For that reason, it does make a difference in terms of physical properties, especially in terms of water relations, whether the sand-sized particles we have in that particular soil are the finer ones or near the bottom end of that range, or are they coarse or larger sized particles that are near the upper end of that range. So other than knowing the percentage of sand, silt, and clay, we would also want to know what size are those sand particles that are in that particular soil.